We've only got one more session for our event today, and I want to welcome to this. I was going to say welcome to the stage. It's been that long since I've been at an in-person event where I'm just not used to the fact that we don't have stages anymore. I would have thought I'd be adapted to that by now. Anyway, I'd like to bring Ezzy up. Ezzy is here to tell us all about, help us navigate this landscape of the various things that we can do with serverless and how we can integrate them all together using the Azure integration application. Ezzy, over to you.
Thanks, Aaron, for this wonderful introduction, and thanks for having me on this show, Azure Serverless Conference. It's a pleasure to be here. So today I'm going to talk about the secret behind building a reactive Azure integration application. And a little bit about me. How am I the right person to talk about this before we get started? I am Ezhilarasi Kesavan. I'm the lead product consultant of Serverless 360 at Kowai.co. Having said, Serverless 360 is a tool for Azure. So we transform the support for Azure serverless applications across enterprises. And this role gave me opportunity to interact with Azure experts, solution architects across various domains across the globe. And I'm here with some of the interesting learnings that I had in the last 4 years out of my total 12 years of IT experience. So my journey, last 4 years with Azure serverless integration space is amazing. And every day turns out to be new learning. And I'm excited to share some of them with you here. So let us get started with a very basic question. What is a reactive application? When do we call an application to be reactive? So according to the Reactive Manifesto, it is expected to have 4 key characteristics. And first and foremost being responsive. So we all know, right, being the consumers and developers of modern applications, we all need an application which is highly responsive. Let us elaborate this word a little more. So to make sure that we build reactive applications. And responsive system is expected to respond in a timely manner if at all it is possible. So responsiveness is a cornerstone for usability and utility. But beyond that, responsiveness also means that problems may be detected quickly and dealt with effectively. Even before the customer realizes that there was a problem with my system, but my application should restore and respond back to the customer. Responsive systems should focus on providing rapid and consistent response times, establishing reliable upper bounds so they deliver a consistent quality of service. This consistent behavior in turn simplifies error handling, builds end-user confidence, and encourages further interactions. So, how can I build a resilient system? So resilient systems should stay responsive in face of a failure. So this applies not only to highly available mission-critical systems. To any system that is not resilient will go unresponsive after a failure, which has to be avoided. But how do I achieve resilience? Through 4 critical aspects: replication, containment, isolation, and delegation. Let me elaborate a bit more on all these 4 factors. Failures should be contained within each component. So, isolating components from each other and thereby ensuring that parts of the system can fail and recover without impacting the entire system is very critical here. And recovery of each component is delegated to an external component, which in which case we can ensure high availability by replication wherever it is necessary. The most important point here is your client should not be burdened with handling these failures. My application is expected to be elastic if I am building a reactive application. When I say elastic, this system is expected to stay responsive in varying workloads. So in real-time scenarios, none of my applications get in static or predicted input ranges, and it keeps changing. So reactive systems should react to changes in the input rate by either increasing or decreasing those resources that are allocated to serve these inputs in real time seamlessly. So this implies that our design should have no contention points or critical bottlenecks, resulting in the ability to replicate my components and distribute my inputs among them. So reactive systems should support predictive and reactive scaling algorithms by providing relevant live performance measures. They should achieve elasticity over cost efficiency. And the system is expected to be message driven. So most of our modern applications rely on asynchronous message passing to establish a boundary between the components that ensure loosely coupling. So isolation and location transparency is also ensured with the help of message-driven architectures. So this boundary also provides a means to delegate failures as a messages. So this also ensures a non-blocking communication that allows the recipients to consume the resources when they are active. So leaving the system overhead out of the context. So as all these terms sound complex, is there an support that I get from the application development platforms that help me build reactive applications at ease, which encapsulates all the complexities and lets me focus on my core business need that I would like to achieve? Yes, we have Azure to save us. What does Azure has got to offer to help me build reactive applications at ease, ensuring all the four integral principles that we just talked about? I have a complete package of enterprise integration platform services that helps in building reliable reactive Azure integration applications. Some or like when I bring all of them on a slide, it might sound like I have a huge bunch of resources to be to pay attention to and to understand. Let me give a glimpse of some of these services which play a critical role in almost industries across domains and enterprises who build mission critical applications. And as we proceed further, I'm going to bring in an interesting use case from a real-time customer scenario, which has been solved with the help of an Azure integration services. So here, the beauty of Azure services that I admire is they fit exactly into your real-time business use case. See, we just talked about delegating failure from a component. So imagine I have certain messages that is coming into my service bus queue that I cannot process at this point in time due to various reasons. That could be system-specific reasons or business-specific reasons. Service bus supports an secondary sub-queue called dead letter queue, wherein I can pile up all my failed messages and I can process them when it is the right time to process. So such features exactly fit into your real-time use cases. Take, for example, logic apps. As many of my speakers before me in this conference talked about the capabilities of logic apps, functions, and Cosmos DB, I need not emphasize more how resilient they are or how capable they are to integrate with external third-party applications seamlessly, and how do they scale on runtime. So all the four pillars that are required for my reactive application are majorly taken care of by the cloud service provider like Azure. Now let us focus on our core business. And we are going to proceed with addressing a real-time business need, and we are going to fit in these integration services into the business need to build and complete end-to-end integration application. Let's get started by understanding the business. Imagine this is for an shipping and logistic enterprise who is decided to build an intelligent fleet management system. So they have vehicles taking care of shipments across the globe, and they wanted to make their system data-driven and more intelligent with the help of Azure. So there is a trend in industries adopting to cloud. Like some of them choose to choose to build their entire business application in Azure, but still there are enterprises who choose to retain their legacy code in their premise and integrate part of their application with the cloud services. So here is one such case wherein the customer has their core business logic still existing in their on-premise system, and they want to expose it to the cloud securely and get integrated with other integration services, making use of their capabilities to build a real intelligent fleet management system. So this is the scenario. Let us expand this scenario further by understanding all other requirements that they have. So to get started with, their vehicles are all implanted with telematic devices, and these devices are capable of streaming real-time information, useful information like what is its fuel condition right now, what is the speed at which the vehicle is traveling, what is its live location. All these necessary data is being streamed by these telematic devices implanted on these vehicles. Now, what do I actually need to solve this business need? First and foremost, I need an event ingester that accepts and stores the stream of events. So this event ingester should be capable of ingesting millions of events per second, and it is expected to scale seamlessly with the scale of my business. And I cannot expect my legacy code running on my on-premise application to handle the events as and when they come in. So I need a cloud storage service that will allow my on-premise application to process these events at its convenient time. And how my application, the core business service, is existing in on-premise. This has to be safely exposed to my cloud services. So I need a service in place which can do this job for me, which can expose the service from my corporate network into the cloud securely without inviting much of changes into my corporate infrastructure. And I need a reliable storage option where my business service can process the data and store the persistent informations too, which would ensure the storage is expected to have business continuity guarantee and enterprise-grade security in place. I need an event routing service. So we are creating a reactive application. So I do not expect my on-prem service to look for the blob container for the arrival of the event that it is required to process. So I have a cloud storage service. I do not expect my business service to keep pinging the storage service to check whether the data has arrived or not. Instead, the system should be reactive. That is, as and when an event is available for my business service to process, I expect to get a notification to my business service, which will inform the business service, yes, the data that you're looking for has come in and you can pick it up for processing. That is how I want this system to work. And following the processing of the information, there are certain follow-up operations that needs to be taken care of. And this invites interaction with third-party applications, which are my clients, that needs to be orchestrated and then taken care of as and when data is being processed by my business service. And here I need to make sure that my business service is completely decoupled from my backend follow-up processing orchestrator. So I need to bring in a messaging service that would decouple the follow-up actions from my core business service. So these are my requirements from the Azure integration space to fulfill the business needs of the fleet management system that I am building. What is the next step? Let us now choose the right Azure services to be fit into these business use cases, and let us visualize our business application now. So here is how I have designed the fleet management system, which is partially on the cloud. So I have an event hub put in the place of an event ingester, which is capable of ingesting stream of telematic events seamlessly. And Event Hub has a wonderful feature called capture. So say when we deal with events, there are two critical processes that needs to be taken care of. One is saving the events and then processing them. this event hub cuts off the overhead of me dealing with saving the events. Let me show you how easy it is to enable saving of events using an event hub. So here is a bunch of resources that I have in my Azure portal to fulfill this business need. Here I have my event hub. I have created my event hub in the standard tier, wherein the capture feature is allowed, and the basic tier doesn't have the capture feature enabled. So it's just a flip of a button. A toggle button will do the job for me with a little bit of configuration. So the complete saving of event overhead is taken off from me. I can now focus on processing this event, which is my core business service. Getting back to the presentation, so I turn on capture on my event hub, which captures the events into an storage destination. So here I have a couple of options. I can choose either an storage account or an data lake storage. So here I have chosen an storage account blob storage. So when I turn on capture, the events that has been received by the event hub from the telematic devices is now saved comfortably into my storage blob. Now the next step is exposing my on-prem business service to the cloud. I have put Relay in place to do this job. So Relay can seamlessly get this attained. So Relay is a reliable service that can enable you securely expose your service that run in your corporate network to the cloud, to the public cloud. So this can be done without opening a port in your firewall or making any intrusive changes in your corporate infrastructure. That's the best part. So I expose my on-prem service through nRelay. And the next step is to make this whole setup event-driven, which is a key in reactive application. So what is a component that is the heart of my reactive application here is Event Grid. So Event Grid is an wonderful service from Azure, which can seamlessly route events from any services to any service. So you have custom binding possible in an Event Grid topic, and you can subscribe to an webhook in an Event Grid subscription. So this makes pretty much Event Grid and the excellent choice to route an event in any scenario for that matter. So in this case, I have an event hub that emits the event to the event grid, which says that a capture file is created. And this event grid passes the event to the relay saying that the file that you're looking for is now available. Now, the on-prem application can comfortably pick up the file from the storage blob and continue with the processing at its own pace. So this part is completely achieved. And next is an follow-up operations that needs to be taken care of. Yeah, so we have collected a lot of data that has been processed to come up with useful information, and this information has to be passed on to the respective clients or respective third-party applications to react on. So that is where I bring in my Logic app, which is an wonderful orchestrator service from Azure, which exhibits a number of connectors, and you can even build custom connectors which can facilitate integration with third-party applications, or a number of built-in connectors would also facilitate building your solution without writing a line of code. And what is necessary here is to decouple the core business service from my follow-up operations, which is defined in my Logic app. So I bring in an queue here. So any commands that is expected to be processed by the Logic app is compiled as a service bus message, then pushed into this service bus queue. And the Logic app, which is listening to this queue, can pick up this message at its convenience and then process it. So as we observe here, we have clearly decoupled all the core components of this business application, ensuring that failure of one is not going to impact the other. The other would continue working without any challenge. So we can make use of the features from Azure, like a geo replication, or ensuring high availability. To ensure high availability, you can make use of dead lettering in the event grid and service bus queues to make it fail proof. And serverless, when we coin the term serverless, it means that seamless scaling. So need not to be sent. You can configure appropriately to make sure that your application is elastic seamlessly. And we have designed the application completely event and message driven to ensure that the components are loosely coupled. So this organization, later I'll also show you a glimpse of event grid in the Azure portal, where then we have an connection to the Azure relay, which is an hybrid connection because it's exposing an on-prem service. And when this application design is also extendable, say this particular scenario, we later decided to replace the on-prem component with an reliable, durable function. So in this case, this in the inserting and function into an scenario is also can be done seamlessly without impacting rest of your business components. So we understood the business needs and we have identified the right services to fit into the business scenario to solve the business solution. So what is next is, as we build these services, it's necessary to adhere to best practices. But actually, this topic itself is can run for an hour or so. So I am giving you the authentic reference wherein you can find tips from experts across the world on serverless. So this is a knowledge base that covers serverless best practices, powerful tips, and latest announcements from top-notch industry experts to help you discover new opportunities and save time within the stack. Some of the very common tips would be like make sure that you adhere to standards when you build your logic apps, say retry policy definitions or error handling. Make sure you take care of these when you build your Azure services. And extensive knowledge on every service that we are working with will help us use them appropriately. Last but not the least, so we have built a reactive application and it's equally important to support them in real time. So you need to define a frictionless support strategy to support your reactive integration applications in production. Azure does offer a handful of management and monitoring tool sets that would help us to have a live monitoring of your resources. To add on to that, let us have a look into a typical support scenario in an enterprise business. So I have various set of users who are involved in supporting my Azure application that is in production. So, but when we look, the Azure portal access is restricted only to designated Azure experts in an organization because it's pretty much harmful to give access to support people on the Azure portal. That's how enterprises admit. So when we look at the typical support, how is it split across the members in the team? We find that it requires an good amount of expertise to deal with real-time support requirements when you are working with a support application. But unfortunately, the business users and L1, L2 support team do not have visibility on the solution that they are dealing with, or there is a security challenge in giving them access to the Azure portal. And the L3 IT support team was present with a limited experience of the solution. How do we tackle this? So what actually ends up happening is most of the support gets addressed by a level 3 IT support team, and 70% of the supports are being addressed by an experienced Azure developer. What is the harm here is you are investing your skilled Azure resource time into the support tasks. Instead, it should be for innovation in your business. How do we tackle this? So that is where a tool like Serverless 360 can pitch in, and we have brought in excellent set of tool set that complements the Azure portal by delegating the support tasks to the IT support teams. So we enable the support team with the right tool set that will help them understand the solution that they are dealing with and proactively react to the issues that occur in them. So we can safely offload the support overheads from the Azure experts, allowing them to focus on innovation, hence reducing the total cost of ownership on your application. How in action? Let me quickly give you a glimpse of this. So I just showed you the resources that I created in the Azure portal to fulfill the business need. And I have the same resources represented in Serverless 360 as an application. So when a support person looks at this representation of the business application in Serverless 360, they clearly point out where the problem is. So they visualize the business application, they identify the issue, they find that the dead letter messages in the queue has piled up. Say if you are not using a premium tier queue, you do not get visibility on the messages in the queue. So that can be addressed with the help of Serverless 360, wherein you get visibility of the dead letter messages, and that can be viewed and processed right from here. So this way, the tool set to fulfill the operational need of an Azure application is provided to the support team. And this can also be automated with the help of automated tasks in Serverless 360. Say any failure in your logic app, that can be spotted in action required and that can be resubmitted to restored. And any real-time tracking of the business application can also be done with the help of business activity monitoring. So this is how the tool can complement the Azure portal in making your Azure experience much better. Same in this scenario that we just talked about, say business user says that a typical support scenario would look like this. A business user asks, is the follow processing broken? I have no idea. Let's raise a support call. We can't see anything. Let's escalate it. This is how the issue gets escalated to the Azure team, and the Azure expert is expected to invest a lot of time in looking into this problem. Instead, when we have a right tool in place, the team can be proactive. They get an alert, they solve the problem even before the issue has been escalated by the business users. So you be proactive and give your customers a wonderful experience when dealing with your Azure application. To summarize all that we discussed today, we understood what are all the requirements of a reactive application as recommended by the Reactive Manifesto, and we understood how to build an application to meet the business needs by choosing the right services from Azure. I gave you the resource link to check on the best practices that you will need to adhere to when you construct your business components. And when you need to define a frictionless support strategy, Serverless 360 is a place to go. So here are some useful links, and thanks for listening to me. I am open to any questions that you have.
Excellent. Thank you for that. That was a really informative session, particularly helping to demystify some of the complexity that we've got around Azure. Unfortunately, we are out of time today, so we don't have any time for questions, but do reach out on social media. But I would like to lastly thank all of our speakers that we had. Give them a big round of applause. And I'd also like to thank my co-host Rahul for jumping in and helping me out with this stuff today. But that's all that we've got. Thanks for watching, and we'll see you next time.